Hello students, hope you must be doing good. We have discussed so many topics so far. Hope you would have enjoyed them. So now I'll be discussing about the third law of motion. This is the most easy to understand and most easy to see that. This third law tells us about when you apply a force on an object, how does it react back to you? That is, to put it precisely, somebody slaps you, you slap him back. So that's jokes apart, we'll try to understand about the Newton's third law of motion, which is basically understanding about when you apply a force, what is the kind of reaction force that you see. Let's try to understand that with an example, with a video to be precise. So again, Professor Mack is going to explain it to us. So Professor Mack here is trying to launch a rocket. So there is a rocket by the name of Mach 1, so he's trying to launch it. So as soon as he presses the launch button, it starts ejecting gas and it moves in the top direction. So what does it tell us? There is nothing which pushed it in the forward direction. There is no other object which can be seen in the close proximity. So why or how did that actually move on to space? Let's now try to understand that. So Professor Mack will tell us about that in this Newton's third law of motion using this concept of the rocket. So for this rocket to be actually moving, let's try to do an experiment, simple experiment, which we actually do it in our day-to-day lives. What happens basically for the motion of the rocket, what we see is that there is an action and there is a reaction. So every action is going to be compensated by an equal and opposite reaction. So when the rocket moved up, obviously there was an action and there was a reaction, therefore. Similar kind of thing holds good everywhere. As you can see, Dr. Mack is standing on this floor. So when he is standing on this floor, obviously he's acting. There is a weight that is acting on the surface. On this particular surface, there is a weight that acts, which is equals to his basically mass times the acceleration due to gravity. But he does not fall down. So if he is not falling down, that means there should be some amount of compensating force which is acted upon by the surface of contact. So here, this is the cross-sectional area. This is the amount of force that is acted upon the floor by Dr. Mack. Dr. Mack is not falling down. That means the floor is also acting upon a force on Mack. So this is what is known as the reaction force. You have the action force here and you have the reaction force given by this. The reaction force is given by the surface of contact. Yeah. So these are the two forces that act on this. Now, since either of them are not making any object move, they are to be acting in opposite direction and it should be equal in magnitude. Similar thing held good for the case of the rocket as well. Let's now try to do another kind of an experiment. Supposing this is a wall. Dr. Mack is now going to try pushing this wall. So when he tries pushing this wall, what happens as a result? There is an action force that is acting on this and the wall does not move by his pushing. That means there should be a reaction force. So the reaction force on the wall, or the reaction force is by the wall, the action force is on the wall. So these two forces, as you can see, have to be equal in magnitude. If he pushes more, he will be pushed in the same amount in the backward direction. They have to be the same size. Even though there are different objects, one is a force on the wall, other is a force on Mack. They are different objects, but the amount of force on each other is exactly the same. So different objects are there, but the amount of force being equal, that means that forces always act in pairs. Which we learned earlier as well, that we need to understand that there are forces which act always in pairs. In this case as well, this was the floor, this was the wall. Obviously both of them in this case acted. Here this results into an interaction of the objects. One object is pushing, the other object is pushing it back. So these are the forces that act in pairs, even though they are different objects that act on each other. So this one force is going to be called as an action force, the other force is going to be called as a reaction force. In this case, what happened? In the case of the rocket, within the rocket you have gases that are present that have to be ejected. So when you burn those gases, as soon as those gases start burning, they are going to push out the fuel in the backward direction. So when that fuel is pushed in the backward direction, that results into the Mach moving in the forward direction. Similar kind of examples can be seen here. When Dr. Mach throws out a ball, or let's say he tries to blow out air, so that results into a motion in the forward direction. In either cases, that results into a motion in the forward direction. But since there is no external force acting, he will be pushed in the backward direction. In the case of the rocket, this was a gas that was present which was burnt, and as soon as it burnt, it went out of the launch pad. Taking it further, now we try to go into Newton's third law of motion. So what does Newton's third law deal with? What did we understand with that? So it deals with the action and reaction pair on a body. So if I say this is the action with which the air out of a balloon goes out, as a result the balloon goes up. Similarly, in here, one of it is the action. So action is the air coming out, and the reaction is the balloon going in the other direction. As a result, we'll also try to understand it separately, the motion of a horse and a cart. So the horse pushes the ground in the backward direction. As a result, the ground pushes the horse in the forward direction. Similarly, if you try to pull the spring, or if you try to throw a bullet out of a gun, in either case, what happens as the bullet moves in the forward direction, the gun is going to be pushed in the backward direction. Why? Because the net force is exactly zero. So the net force has to be balanced, and therefore the momentum given to one object has to be compensated by the motion of the other object. That is what we have in this. So this is what we understood in the Newton's third law of motion. We'll discuss about the conservation of momentum as well as the motion of the horse and the cart in our separate lectures. Thank you. So students, we learned about the third law of motion. The law states that every action would have an equal and opposite reaction. So now you would have understood that even though you are standing on the ground, you are not falling down. Why? Because the ground pushes you back. So hopefully this concept of third law of motion is clear to you. We'll understand more about how exactly the forces interact, and when there is an absence of force, when there is an absence of a unbalanced external force, in that case what results. That is, we'll be discussing about the conservation of momentum in our next topic.